today we're talking about sine, cosine, and tangent again, but we're talking about the opposite of sine and the opposite of cosine and the opposite of tangent. So we need to back up a moment, and before we get into any of this, let's just kind of make that disappear for a moment. Use this space over here. We need to talk about what we mean by inverses. All right, so oftentimes when you are working in algebra, let's kind of go back to last year in Algebra 1, you may have had equations like y equals 2x. Okay, we'll keep it simple here. So here's a little mini example, right? Now you might have learned about something called function notation. X is your input, y is your output, right? So if I plug in an input of, say, 5, well then your output, your answer is 10, because 5 times 2 equals 10. But you might have shown that with something called function notation, all right? So you may have encountered equations with this very fancy symbol, and that still means an output, all right? You plug in a 5, x is the symbol communicating that you are plugging in 5 in place of x, and 5 times 2 is 10. So your answer, your output is still 10. Now, if you learned how to find the opposite function, what we call the inverse function, there was a whole process of algebra that you went through, and we're not using that process here, but I'm just talking about the symbol that we use to communicate the opposite equation, the opposite function, and that looked like this. Do you remember seeing that symbol right there? This is the opposite symbol. This is the opposite equation to this equation. And this symbol here, this is not an exponent, so don't say the function to the minus 1. No, no, no. We say it's the inverse function. It's the function inverse. So when we're talking about inverses, we're talking about the operation that is the opposite operation. For example, this is 2 times x. So what's the opposite of multiplication? Division. This is communicating the opposite operation. All right? So if we have sine, for example, and there's my input. I'm using theta as my input. Sine theta equals something. Let's give it. We'll just call it opposite over hypotenuse, right? We need a symbol to communicate the opposite operation, and the opposite operation of sine is sine inverse. Look at that. So you can see that's what, this is kind of a mess here. This is just copied from, I think it's from our textbook. But that's what you see here. This is tangent inverse. This is sine inverse. This is cosine inverse. You can call it either inverse cosine, or I'll take cosine inverse. But don't call it cosine to the minus 1, because it's not an exponent. It's just a symbol that says it is the operation that is going to be exactly opposite to the original operation. Just like multiplication and division are opposite operations and they cancel themselves out, sine and sine inverse will cancel themselves out. And that's very useful, because if you can make this cancel out sine, then it gives us a way to solve for a missing angle. So that's what we're trying to do today. We're going to solve right triangles. And when we say the phrase solve a right triangle, we mean find the measures of everything. Find the measures of all the missing sides, which we've done previously. We've been finding missing sides. But we also want to find all of the missing angles. And this is going to be new for us today. How to use the trig ratios backwards, meaning the inverses of them, the opposites of them, to find the missing angles. We're going to do that in a moment. So we've talked about how trigonometry is describing ratios of sides of the triangle, right? But you always have an angle included in that, right? So you're always using a reference angle. The inverse trig ratio, still setting up a ratio. We're still using 2 sides of the right triangle, but we're going backwards now so that we can find angle measures. So what that means is if we're finding the sides, like in the past, we could use Pythagorean theorem if we had enough information. We could use sine, we could use cosine, and we could use tangent. But if we want to find missing angles, we might have to use inverse sine, or inverse cosine, or inverse tangent. So take a look at example number 1. Here in part A, you have sine of angle A equals 0.76. Now, we've often been using just fractions to represent the ratios. And if you see a decimal here, that might be hard to recognize that this is still the ratio of two sides of a triangle. So I'm going to modify this a little bit. Let's represent this as a fraction. So just kind of cross that out. Pretend the problem says sine of angle A equals 76 over 100. Okay? We know the sine ratio is the opposite side over the hypotenuse. So if we were to represent this with a picture, here's my angle A. We don't know how many degrees it is, but we can still label all of the sides. So here is the hypotenuse. Here's your reference angle, which we don't know. There's the opposite leg. And here's the adjacent leg. So we've learned how to do that. So if sine is the ratio of these two sides, opposite over hypotenuse, then we know the 76 can go here on the opposite leg and the 100 on the hypotenuse. This is just a picture to show you what these numbers are trying to communicate. Right? Those are two sides of our triangle. Notice we don't know what the angle is, but now we can, because we said we can use inverse, the opposite of sine, inverse sine, to find a missing angle. That's exactly what we're going to do. So I'm going to give myself a little bit more space and rewrite this again. Sine of angle A equals, give yourself more space, and then there's your ratio of two sides. Just like we said, multiplication and division are opposites of each other, just like addition and subtraction are opposites of each other, we need to get angle A by itself, but we have to get rid of sine. How do we get rid of sine? We need the opposite of sine. You can't just divide sine away, because sine is not a number. We need the opposite of sine. So that's where we bring in the special symbol of sine inverse. And you have to do that on both sides, like this. All right? So you can't divide away sine, because sine is not a number. You have to do the opposite of sine, which is sine inverse. And this is what we're saying. An operation and its opposite operation are going to cancel themselves out, just like addition and subtraction would cancel each other out. So what we're seeing here is that on the left-hand side, sine and its opposite cancel each other out, and all you have left with now is A. But that's an angle, so you have to update your geometry notation and put the measure of angle in front of that capital letter A. Now this is what we type into our calculator because the variable is now by itself. We can now go to the calculator. And so you'll notice here on your calculator you have your sine, cosine, tangent button right there in the middle, and right above that is sine with that little -1 floating above it. That's your sine inverse, cosine inverse, and tangent inverse. So to find those, you have to hit the second function button to activate that second function above the main function. So let me turn this on. There's my second function, there's my sine inverse, and you'll see it looks like sine inverse with that little -1 floating above it. I'm going to plug in 76 divided by 100, and then make sure you close the parentheses like that, because you are taking this of the entire fraction. And that will give you an angle measure, right? So this is not a side length anymore. That's our angle in degrees. So again, we'll round to 2 decimal places. So 49.46. Now I spent more time on this one just to introduce the concept and the notation. It doesn't really take that long. For example, here in part B we have cosine of angle B equals 0.17. How do we get rid of cosine? You need the opposite of cosine. You need cosine inverse. So you take cosine inverse of each side. On the left-hand side, cosine and its inverse cancel out. Angle B is all by itself. Update your notation like this. The variable is by itself. That's what you type into your calculator. So now we want second function followed by the cosine button brings up the cosine inverse. And then we use the decimal value of 0.17. That is 80.21 degrees. And we could do that also with tangent. We're trying to solve for angle A. How to get rid of tangent? You need its opposite. You need tangent inverse. So take tangent inverse of both sides like this. And again, the tangent and its inverse cancel out. That's how you get the angle by itself. Update your notation. And this is what you type into your calculator now. So inverse tangent, right? So you hit the second function button followed by the tangent button to bring up the tangent inverse. And then, what was that, 0.8? We have 0.8 there. So this is in degrees, 38.66. Don't forget the degree symbol now. So that's the basic concept. All right, so now we're going to take a look at a variety of different triangles. We have them on the front page. We've got more on the back page. We're going to take a look at a different situations here. And we're starting off with solving these right triangles. So at the top of the page we said solving the right triangles means finding all the sides and all the angles, which means we have to find a lot of information there. So let's take a look at part A. And you can see that we do have a right angle, but we don't have angle A or angle C. Those are missing. All right. We do have the height of 16, we have the base of 20, but we're missing this side here. All right. So we have three things to find. We have two angles to find and one side. So that's three items that we have to find. So as there's a lot of work, we need to stay organized here, and you need to identify what it is that you're going to find so that we can match the work to that part of the problem. So let's start off with the side. This is side AC, and we've done this before. We have two sides already on a right triangle, so we can just use our Pythagorean theorem, right? So 16 squared plus 20 squared equals this side, which opposite capital B is little b, so let's call that little b squared. Right, so notice we're not using sine, cosine, or tangent here because we don't have a reference angle to use. We have two sides anyway. So let's see, what do we have here? 656. This is the inverse, right? We're talking about inverses today. We're talking about operations that are the opposite. What is the opposite of a power of 2? The square root, right? We say the square and the square root cancel themselves out. We call those inverse operations. Those are opposite operations. All right. Notice we're not simplifying the radical. We're just going right to a decimal value. So 25.61 is that length. Now we have two angles to find. It doesn't matter which one we find first. We could find them in either order. I'll just find A. So since that's the angle that I'm choosing to find, that becomes the reference angle. Now we're going to label all of our sides relative to angle A being the reference angle. If you chose angle C, you would label all the sides with C being the reference angle. So opposite the right angle is the hypotenuse. Opposite the reference angle is the 16, that's your opposite leg. And the 20 is next to the reference angle, so that's your adjacent leg. Now we have all three sides with numbers. We just have to pick two sides to create a ratio, but if you can, always pick the printed numbers, because what if I made a mistake and this is not the real length? I don't want to use a mistake in my next ratio. So always go back to the printed information if possible. So let's use the 16 and the 20. That's the opposite and the adjacent side, so that is the tangent ratio. Tangent of the reference angle, which we don't know, that's angle A, so there's your capital A. Tangent equals opposite over adjacent, so that's the 16 over 20. All right, how do you get A by itself? You have to get rid of tangent, but you can't divide it away. Tangent is not a number, it's an operation. So you have to do the inverse operation. You have to take the tangent inverse of both sides. And then the tangent and its inverse cancel out. There's your angle A all by itself. The measure of angle A equals, and this is what we type into our calculator, just like what we did in the previous example. Tangent inverse, left parenthesis, 16 divided by 20, and then close the parenthesis as well. So when we do that, we will now have 38.66 degrees. So the very last item to find is angle C. Now we have two options here. We could mark that as a reference angle, label all the sides all over again, and pick the right ratio, which will also be a tangent ratio if we were using the 20 and the 16. But we have another option. We do know that all three angles add up to 180 degrees, so you could simply subtract everything from 180. We're subtracting a 90-degree angle away, and the 38.66 degree angle, and what's left over is angle C, 51.34. So notice that we're using a variety of methods that we've learned in the past. We've learned the triangle sum theorem, how all the angles add up to 180 degrees. We've learned the Pythagorean theorem before and how to use that to find a missing side. We're using SOHCAHTOA. We're using the tangent ratio here, and then its inverse to work backwards to find a missing angle. So you have to pick and choose what method you want to use in each of these situations. So I want to take a look at a few other diagrams where we're really focusing on the inverse trig ratio. And that's not this one here, so I'm going to flip over to the back side. And we have a couple more diagrams. It's represented as story problems, but you'll see that in each case we're trying to find a particular angle. Let's take a look at a couple of these. All right, so example 3 says you are building a track for a model train, and you want the track to incline, that means to go up, incline from the first level to the second level, 4 inches higher, so there's your 4-inch height, within a span of 96 inches. We want to know, is the angle of elevation less than 3 degrees? So if you have a model train, it might have a very weak engine. It might not be able to go up a hill. If it's too steep, we have to make sure that the angle of elevation is within a certain amount. And so they're saying, is it less than 3 degrees? Because then the train can go up the hill. All right, so because this is the angle of elevation, and it's marked with an X, that's our reference angle. All right, so now let's label all the sides. Opposite the right angle, there's your hypotenuse. Opposite the reference angle is the 4 inches, so that's the opposite leg. And the 96 is your adjacent leg. So again, what we want to do is we want to pick two sides to build a ratio. We'll pick the 4 and the 96, that's the opposite and the adjacent, so that's the tangent ratio. Tangent of, they're calling it X, equals opposite over adjacent. All right, so we got to solve for X. We have to get rid of tangent, but you can't just divide it away because it's not a number. We want the opposite of tangent, so we'll take the tangent inverse of both sides. And so the tangent and its opposite cancel out, and that's how you get X. Now, that's a variable, so we'll keep it as a variable X, and we're going to type that into our calculator there. So you get a result of 2.39. Yeah, that is less than 3 degrees. Here's another situation. Example 4. This time we have a driveway, all right, and the driveway is 25 meters long. It's built on an incline, so again, we're going up the hill. It has risen a distance of 4 meters. So that risen is meaning height, so your 4-meter height goes here. It has risen a distance of 4 meters by the time it reaches from one end to the other. So when you start here, you're at height 0. You drive 25 meters up the driveway, and now you're 4 meters higher than when you started. What is the angle of elevation? All right, so there's your angle of elevation. That's my reference angle, so let's label all the sides. Opposite the right angle is your hypotenuse. Opposite the reference angle is the opposite leg, and here's the adjacent leg. Let's build a ratio. We'll use the 4 and the 25. That's the opposite side and the hypotenuse. That's our sine ratio. So sine of theta, that's my variable for angles, equals this ratio of opposite over hypotenuse. All right, there it is. Let's take the opposite of sine now. So this is sine inverse of both sides. The sine and its inverse cancel out. There's your theta, there's your variable for angles. That's what we type into the calculator now. And round to 2 decimal places, we get 9.21 degrees. So we have one last example that I want to take a look at here, example number 5. And the reason why I want to look at this one is because due to the nature of the way it's drawn, because of the stairs, it's a little more challenging to figure out what's going on. Not real hard, but we just have to address this here. So here we have our stairs, and it says that each step of a stairway rises 18 centimeters. So that's the height, because you're going up, it's rising. For a tread width, this is the tread width of 32 centimeters. What angle, theta, does the stairway make with the floor? Now, the way this is drawn, this is the floor, right? So this whole thing that you see here, that's the floor. And so this angle is representing an angle of elevation like that. And this slanted line is going from one stair tread to the next stair tread and taken over the whole span of that. It's giving you that incline as it goes uphill. Even though you're stepping up vertically and moving horizontally, you can connect those dots there to kind of give you this sense of an incline, which is that angle. How many degrees incline does that stairway make? The problem is that this is our triangle, and this angle here is outside the triangle. So we need to somehow get the triangle down here. And that's okay. You can essentially think of this like a big rectangle. And if you drop this height from the second tread down and use the floor and use that right there, you essentially have a rectangle divided into 2 right triangles. So in other words, this 18 centimeters is also here, and the 32 centimeters is also here. I'll enlarge this slightly. This is essentially what I'm focusing on. There's the floor on the bottom. There's the theta. That's your angle of elevation right there. There's your 18, and there's your 32. All right, so let's label our sides. Here's the hypotenuse. Here's the opposite leg. Here's the adjacent leg. And we're going to use the 18 and 32 to set up a ratio. And so let's use tangent. So tangent of theta equals my opposite over adjacent. Let's solve for theta. Let's get rid of tangent. We want the opposite of tangent. We write tangent inverse on both sides. Tangent and its inverse cancel out. And there's your angle theta all by itself. So now we can type this in our calculator. 29.36 degrees is what we get.